Let's do another question. Question 6. What are the amplitude, frequency, and phase constant of the oscillation shown in figure 15.6? This one. I'm just gonna give you a moment to pause the video if you wanna try it by your own. So this question is also a very easy question to do. Let's start by the first part, amplitude. To find the amplitude, we don't need to do any calculation at all. It's pretty easy. We just need to look at the graph. The extremity of this graph is 10 centimeters. From the 0, and again from 0 to minus 10. This is our positive amplitude, this is our negative amplitude. So the amplitude here is 10 centimeter or 0.10 meter. I'm just gonna clean the graph. Okay, so we found the first one. Let's do the second one. The frequency. Frequency is, so to find the frequency, we need to remember one of the equations. Frequency is the inverse function of period, which means the number of one cycle per amount of time. It means how long does it take for a complete cycle. Here we see for a complete cycle, it takes 4 seconds. So the frequency here is going to be a quarter or 0.25 hertz. So that is the frequency. Also, let's just calculate the period. Period is going to be 4 seconds. Now it asks us for the phase constant. For the phase constant, we need to remember one of the equations, the equation of position as a function of time, which is x as a function of time equals amplitude times cosine times omega t plus phase constant. So at time 0 second, based on the graph, x is located on minus 5 centimeter or minus 0.05 meter. Let's plug this value into our equation to find the phase constant. So it's going to be minus 0.05 meter equals 0.10 meter times cosine of, we know the omega. Well, we don't know the omega, but we don't even need to know the omega, because omega is going to multiply by 0 second. It's going to be 0. So why do we even need to bother ourselves to write it, right? So it's going to be cosine of phase constant. Let's just do this easy equation. This is minus 0.05 meter divided by 0.10 meter equal cosine of phase constant. Let's just take cosine to the other side. It becomes arc cosine of this value. Let me just plug it into my calculator and find it out. Minus 0.5 equal phase constant, then it becomes phase constant becomes positive negative 2.09, which is, or positive negative 2 pi over 3. Let's just look at our graph to find out whether it's going to be positive 2 pi over 3 or negative. Here, based on the graph, we see that it's almost left here. Let me just draw the reference circle. Here is minus pi over 2 our equilibrium. Here is also pi over 2 our equilibrium. Here is our positive amplitude. Here is our negative amplitude. So here is negative amplitude, positive amplitude, equilibrium. The 2 pi over 3 minus 2 pi over 3 is located here. And 2 pi over 3, the positive one, is located here. From the graph, we see that we already left the minus amplitude. And we are almost on the way. We are almost here. We are on our way to the other equilibrium, the second equilibrium here, to the positive side. Because you see here, we are moving to the positive amplitude. So based on the graph, this is the right one to choose. The minus 2 pi over 3. Minus 2 pi over 3. This is our phase constant. We're just gonna rewrite our position as a function of time equation to plug in our phase constant in it. It's gonna be xt equals 0.10 meter cosine omega t minus 2 pi over 3.